Hey there, folks. In this edition, we are going to be making an answer key to our day one review for Unit 4. One thing that I want to highlight real quick, in case you didn't read your directions here, make sure you've got a separate sheet of paper handy because some of these problems just take a lot of room. They're not necessarily difficult, they just take a lot of space. That being said, I've got some notebook paper right here. All right. So number 1 and 2, these are long division problems, foreshadowing anyone, um, the fact that we're probably going to want to use a separate sheet. So on number 1, my divisor is going to be 2x plus 1, and I'm going to divide that into my dividend, which is 2x to the third plus 9x squared, plus 14x plus 5. Now, again, when we do these, we want to make sure that we don't skip any terms, right? So it goes to the third power, to the second power, first power, and fifth. And I'm sorry in advance for this autofocus kind of tweaking out. Let me see if I can hit a button to remedy that. Maybe? Nope. Hold on, folks. All right, hopefully this does the trick. Okay, so what we want to do is figure out how do I turn this first term into this first term? Well, to turn a 2x into a 2x cubed, I need to multiply by an x to the second power. So then off to the side, I'm going to distribute that x to the second power into a 2x plus 1. In doing so, we'll get 2x to the third and a positive 1x squared. And we need to find the difference. So when I find the difference, I need to make everything become the opposite. So whatever was positive is now negative, negatives turn positive, so on and so on. First terms will cancel. 9x squared minus x squared, I get 8x squared, and drop down everything else, plus 14x plus 5. Now we start that process over again. How do I turn a 2x into an 8x squared? Well, I need to multiply by a positive 4x. So off to the side, I'm going to take that 4x and distribute it into my divisor, which is 2x plus 1. 4x times 2x is a positive 8x squared. 4x times 1 is a 4x. I need to find the difference, so everything becomes the opposite. Positives go negative, negatives go positive. First terms cancel, yay. And then I'll have 10x plus 5. And now we do the whole thing over. Turn a 2x into a 10x by multiplying by 5. And off to the side, I'll take my 5 and distribute it into my divisor, which is 2x plus 1. That gives me a 10x and a 5. We find the difference, so we switch to subtraction. First terms will cancel. And hey, the 5's also cancel. So I have a remainder of 0, which is awesome. We like seeing 0 remainders, which then means this is my quotient up top. X squared plus 4x plus 5. Sweet. All right, number 2. It looks like number 2 is going to require the same amount of space, so I'm going to do it on a separate sheet yet again. One thing to make note of with number 2 is we've skipped the x squared term, right? We can't just go from an x to the third to a plain old x. We need to have a space holder. So I'm going to include a 0 in there just to make sure that we have that filled. So x to the third plus 0x squared minus 13x minus 12. All right. By the way, for the 0x squared, you could put a plus, you could put a minus. It doesn't matter. It's a 0. 0 has no sign. Turn an x into an x cubed by multiplying by x squared. Then off to the side, we're going to take that x squared and multiply it into our divisor, which was x minus 4. That will give us an x to the third minus 4x squared. And we need to find the difference, so we are changing the signs on everything. So what was negative goes positive, positive go negative. We combine straight down, first terms cancel. Here we've got 4x squared minus 13x minus 12. To turn an x into a 4x squared, I need to multiply by a 4x. Off to the side, I'll distribute that 4x into my divisor, x minus 4. That would be 4x squared minus 16x. So 4x squared minus 16x. But I'm finding the difference. So anything that was positive turns negative, negatives turn positive, first terms cancel. Add straight down, I get 3x minus 12. to turn an x into a 3x, I need to multiply by a positive 3. Off to the side, I'll distribute that positive 3 into my divisor, which was an x minus 4, giving me a 3x minus 12. Change the signs to find the difference. First terms will cancel. And another remainder of 0. Oh, happy day. Look at us go. Right on. All right, so that is long division. And as the name implies, it takes a long time to do. All right, let's get into everyone's favorite now, synthetic division. So synthetic division, we're going to use the x-intercept that would come from this factor here. So -2 plus 2 would give me a 0. And then I'm going to steal the coefficients 1. I need to include a 0 because I've skipped a term. A -6, another 0 because I skipped the x, and then a -27. And this is going to be the process where we drop the first term down, so that's a 1. Then we go down, diagonal, down, diagonal, down, diagonal. We add straight down, multiply diagonally. So I'm going to multiply by -2 every time. Add straight down, multiply by -2. So that's going to give me a 4. Add straight down, multiply by -2. Add straight down, multiply by -2. So I've got 1, -2, -2, 4. We always want to make sure that we're not making goofs when it comes to negative signs. So if I combine those like terms, I get -35. And that last number is always my remainder. If this was an x to the 4th, that means my answer, my quotient, will start off with an x to the 3rd. So I'll have 1x to the 3rd minus 2x squared minus 2x plus 4 minus my remainder of 35, and that goes over my divisor, x plus 2. Not the prettiest in the world, but hey, that was a heck of a lot faster. All right, number 4, doesn't look like we skip any terms, so that's awesome. 1's going to go on the outside, and coefficients go across here. Drop the first number down, and every time we go diagonally, we're multiplying by a 1. So this would be a 1 here, 4, a 4 here, then a 3 here, and sweet, we got a 0 remainder. We love 0 remainders. We're going to have 1x squared plus 4x plus 3, no remainder. That's our answer. Great. The remainder theorem is going to essentially be synthetic division, but we focus on the remainder number, and that's going to tell us the function value for a specific input. So if I want to find the function value at -1 for this f function, I'm going to do synthetic division. There's no skipped terms, so I don't need any filler zeros. So we're going to go through and do synthetic division, and I'm going to get the same answer I would if I just plug -1 in for x, but I'm not using a calculator here, so that's not really an option right now. All right, so -1 times 3 is -3, that's -8. Now +8, that brings us to 10. Now -10, so that's a -7. Now +7, so that would be 5. So f of -1 equals 5. Do the same thing with 2. We've got 3, -5, 2, 3, -2. We'll do our synthetic division. Every time we go multiply diagonally, we're going to multiply by 2 this time. So we'll drop the 3 down. That gives us a 6, 1, 2, 4, 8, 11, 22. 20 is our remainder, so the function value here would be 20. Now, you guys might be freaking out here with the last one because we have 2/3. Fret not. Fractions are numbers too. All right? All you have to do when you're multiplying numbers by a fraction is just multiply it by the numerator and leave the denominator alone. If you can simplify, great. If not, leave it as a fraction. We drop the first number down, so that's a 3. 3 times 2/3. 3 times 2 is 6. All over 3 is just 2. Add straight down, I get -3. If I multiply -3 by 2/3, well, I'm going to get a -2 this time. Add straight down, I get a 0. Well, 0 times anything is 0. 3 plus 0 is 3. 3 times 2/3 is 2. Hey, we got a 0 remainder. Excellent. So there we have some fundamental theorems going on with the remainder theorem. Awesome. Next up, we want to find all of the zeros. So sometimes they might have 3, 4, 5, 6, 7, whatever for these values. So we are assuming that there's already a 0 given to us at -3. So I'm going to divide that out and see what we're left with. So I'm going to use synthetic division to divide that out. And I already know the remainder should be 0 because they're telling me we have a 0 there. So let's just zip through that relatively quickly. Awesome. So I'm left with 2x squared minus 11x plus 5. Then I'll try to factor that out. I know it has to start off with a 2x and a 1x. If I put a 5 here and a 1 here, that'll give me a 10x and a 1x. If I make those both negative, then it would add up to -11 in the middle. Cool. So I've got x equals -3 as one of my answers, then x equals positive 1/2 from this factor here, and x equals positive 5 from there. Number 7, no skip terms. They give us a factor. That's the same as giving me an answer. So I have one of my solutions and I can expect 3 total. So now, excuse me, all right, we can divide out a 4 using synthetic division. 2, 7, -53, -28. We can expect the remainder to be 0. If it's not 0, then we goofed somewhere. Drop down the first number. Every time we go diagonally, we multiply. Ooh, 15 times 4 is 60. Okay, so now we're at 7, 28. Sweet. So I've got 2x squared plus 15x plus 7. I need to factor that. I know this has to be a 2x. This has to be a 1x. If I'm trying to get a 7, it's got to be 1 and a 7. So I'm going to think 7 goes here, 1 goes here. That would be 14x, 1x. Yeah, if those are both positive, that adds up to 15. So then x is -1/2, and x is -7. There are my 3 answers. Excelente. All right, 8 and 9. We know one of the zeros is at -3. Here we skipped over 2 terms, right? So I'm going to have to include a 0 for the x squared and the x. So I'm going to expect 3 total answers. They give us 1. I need to find the other 2. All right. So I've got -3 on the outside. 1, 0, 0, 27. If we do it correctly, this should be 0 for the remainder. Drop the first number down, multiply by -3 every time. So basically what's happening here is we're getting powers of 3, and they're alternating the signs as it goes down. So now I've got x squared minus 3x plus 9. Well, that doesn't factor, which means I have to do completing the square or quadratic formula. I'm not a huge fan of completing the square when there's an odd number, so let's do quadratic formula. Opposite of b plus or minus the square root of b squared, that'd be 9, minus 4 times a, which is 1, times c, which is 9. So that'd be 36. 9 minus 36 is -27. So -27 means that there'd be an I on the outside, okay? All over 2a, well, my a value is just 1. So 3 plus or minus I rad 27 all over 2. Sorry about the obnoxiously huge radical there. All right, last one here, number 9. They tell us we have an x-intercept at 1. They give us a factor that's also the same as giving me an x-intercept at -1. So what I'm going to do is synthetic division twice. I'll take this -1 out first, and I'll do the +1 second. All right, so I've got the -1. No skipped terms. Okay, so we've got 1, 2, 2, -2, -3. Do our synthetic division. We should expect that the remainder is 0. Awesome. And now I'm going to do synthetic division again, but stealing these numbers, 1, 1, 1, -3. And every time we go diagonally, we multiply by 1. All right, I'm going to run out of time here, so part 2 of this video is going to carry on, excuse me, where this one left off. So stay tuned there, folks. Stay tuned.